Welcome to May 26 LeetCode Challenge, number of 1 bits. Write a function that takes an unsigned integer and returns the number of 1 bits it has, also known as a Hamming weight. Yep. So note that in some languages such as Java, there's no unsigned integer type. In this case, the input will be given as a signed integer type. This should not affect your implementation, as the integer's internal binary representation is the same whether it's signed or unsigned. In Java, the compiler represents the integer as 2's complement notation, so therefore in example 3, 31 is actually represented by -3. So example 1, we have the Hamming weight of this binary integer is 3. We see that we have 1, 2, 3 number ones in this entire 32-bit integer array, binary array, so therefore the Hamming weight is 3. Similarly, we have 1 ones in this 32-bit binary number, so therefore we have the Hamming weight of 1. And the last one here, example 3, we have everything being 1 except for this number 0 here, and therefore we have 31 ones as an output for the Hamming weight. So the constraints are that the input must be a binary string of length 32. And we have a follow-up question here: is the function if this function is called many times, how we optimize it? So we'll talk about that too. So if we go through the naive approach, let's say if we were to iterate through each index in this 32-bit array, integer array, then we could actually just sum up the number of ones inside it as well, right? That would be pretty easy. So we're gonna do that just as an approach to see if that works or not. So the main idea is to find the number of set bits using a masking operator. And mask, I'll talk about mask in just a bit. So say we have, if we were to take for each value n in our value here, and we mask it with an and operator, so any value that's 1 will be 1, right? So we use an and operator there. So what we want to do is, so if we actually want to find the Hamming weight, which is the sum of all the ones in this binary integer array. So to do that, we just take the sum of n and I bitwise manipulation, no, 1 bitwise shift by I. If that is not equal to 0, and this should go right here. If that's not equal to 0, for each index in the range of each index I in range of 32. And that should find all the ones inside the 32-bit integer array. String, I should say. Let's run this code. So this is kind of the naive approach. It should work. It's not very, we know we just take advantage of that's 32 bits. Another method is that we could actually just use bit manipulation, which is a little bit quicker. So the max number of iterations in the algorithm is the number of set bits in the input n. So what that means is that it's not going to be a one-line code again, but it'll be pretty close. So we have, say we keep a track of count here, and while n exists, what we could do is increment the count by 1, of course, and then we do a bitwise manipulation on the spot for each while the while loop is still within the while loop. It's kind of similar to what we had before, and it'll be n minus 1 this time, and then we just return the count once it exits the while loop. And this should also work as well. This is let's see, this is quicker. This should be time complexity of big O of constant time. Wow, that actually is not very good. Alright then, let's just go with the previous approach there, and that works a little better. There you go. And that is the solution. So we have a time complexity and space complexity of big O of n. Big O of constant space, actually. Because the max number of bits in the input is n, and n is bounded to 32 bits. And that is all. Have a great day, guys.